Hey, welcome back. Today, we are cracking open one of the most fundamental tools in all of statistics, the z-test. It's a super powerful way to figure out if what you're seeing in your data is a real discovery or just noise. And by the end of this, you're going to know exactly what it is and when you should use it. All right, let's start with the one question that is at the absolute heart of all data analysis. When you see a small difference between two numbers, how do you know if it actually means something? Is it a real, significant finding, or could it just be a total random fluke? So to make this real, let's look at an example. Imagine we know for a fact that the average height for an adult in a big city is 170 centimeters, okay? Now let's say we go out and grab our own random sample of 50 people, and their average height turns out to be 172 centimeters. So here's the big question. Is that 2 centimeter difference a genuine finding, or could that have just happened by pure random chance? And that puzzle right there, figuring out if a difference is real or if it's just random, is exactly what researchers and data scientists deal with every single day. It's how we figure out if a new drug actually works better than the old one, or if that new ad campaign is really bringing in more customers.
So you might be wondering, how in the world do we solve this puzzle?
Well, statisticians have a very specific tool in their toolkit made for this exact job. It's called the z-test. You can think of the z-test as a formal process for checking if the difference you found is statistically significant. But, and this is a big but, there's some important fine print. You can only really use it when you already know some key details about the entire population you're studying, specifically how spread out all the data is, which we measure with something called standard deviation. And just like any specialized tool, you can't just use the z-test for everything. It's got its own little user manual, and there are two very clear conditions you have to meet before you can even think about using it. So here they are, the two golden rules. First, your sample has to be big enough. And second, you absolutely, positively have to know the standard deviation of the whole population you're comparing it to. If you can tick both of those boxes, then yeah, the z-test is the perfect tool for you. So, what do we mean by large? Well, in the world of statistics, the magic number, the rule of thumb that everybody uses is 30. If your sample has 30 or more people, or items, or whatever you're measuring, you've met that first condition. You're good to go.
Okay, so we know what it is, and we know when to use it, but how does it actually give us an answer? The great news is we don't need to get bogged down in a bunch of scary formulas. We can just look at the simple, logical steps it follows.
It's really just a four-step process. First, you measure the difference. In our case, that was 2 centimeters. Next, you calculate something called a z-score. That's just a standardized number that basically tells you how unusual your finding is. Then you use that z-score to find a p-value. And finally, you take that p-value and compare it against a specific cutoff number to get your final answer. So what on earth is a p-value? Honestly, the best way to think about it is as a surprise index. It tells you the odds of seeing what you saw if there was actually nothing going on, if it was all just random chance. So a really, really small p-value means your result is super surprising. It's like the data is shouting, whoa, this would be a crazy coincidence if it was just random, which suggests it probably isn't random. And this right here is the finish line. That magic cutoff I mentioned, it's 0.05 or a 5% chance. If the p-value you calculate is less than 0.05, then congratulations. You can officially say your finding is statistically significant. So for our height example, if our p-value came out to, say, 0.02, we could say with confidence, yep, our sample group really is taller than the city average. Now, to really become a pro at this, it's super helpful to compare the z-test to its close cousin, the t-test. Knowing when to use one versus the other is a total game changer. And the choice between them really just comes back to those two rules we talked about. You use the z-test when your sample is large, remember, 30 or more, and when you know the details of the whole population. But if your sample is small, or if the whole population is a total mystery, that's when you bring in the t-test. It's all about using the right tool for the right situation. So if you remember just one thing from all of this, let it be this. Z-test is for big samples when you know the facts about the population. T-test is for small samples, or when you're flying blind without that population data. That simple difference will pretty much always point you in the right direction. And that's the z-test in a nutshell. But really, this is just the beginning. Now that you have this new way of looking at the world, this lens to tell the difference between a real finding and just random noise, what else could you test? You know, that tiny difference in your commute time on Mondays, or the feeling that one brand of battery lasts just a little bit longer. You now have the idea of how you'd actually find out if those feelings are real. So keep questioning.